Hey everyone, this is Dr. Walker, and this is video 204. It's called Transfer of Charge. So we just saw in the previous video there was a cute little applet with John Travoltage, and we saw that we got shocked, and we did see that charge was transferred from our body through our body to the doorknob, and that's when he received a shock. So I want to show you one more applet so that we can make some generalizations and get some good ideas about how charge is transferred. This is called the balloon applet. It's also from PhET. So what I'm going to do is I'm going to rub the balloon on the sweater, and then I'm going to put the balloon right back here, and I want you to think about what is going to happen to the balloon. Is it going to move towards the sweater? Is it going to stay put, like here, if I let go of it, it stays put? Or is it going to go toward the wall? So think about it and let's take a look. I'm going to rub it on the sweater, and then I'm going to put it back here. I'm going to let it go, and it goes toward the sweater. So let's go ahead and take a look and see what is actually happening. Let's show the charges. So the first thing is that objects are usually going to be neutral before you start rubbing them against each other. Neutral meaning they have the same number of positive and negative charges, so the net charge is 0. You see that all the positives are balanced by negatives on the sweater, balloon, and the wall. So what happens when we rub the balloon on the sweater? You notice that the balloon is taking up some negative charges. The sweater is losing some negative charges. So negative charges are transferred from the sweater to the balloon. So the result is that the sweater is now positively charged because it has more positives than negatives. The balloon is now negatively charged. And we learned earlier that opposites attract. So the positive on the sweater and the negative on the balloon, they're going to attract each other. And that's why when I let go of the balloon, it gets attracted to the sweater. I'm going to show you one more thing while we're here. And that is what happens when we bring it toward the wall. If we don't bring it that close, then it's still going to go toward the sweater. But if we bring it close enough to the wall, what we notice is that this negatively charged balloon here is really pushing away the negative charges in the wall. And if it's close enough, then it does get attracted to the wall. And that is why you can rub a balloon to your hair or a sweater, and then it will stick to a wall. So what's happening here is a little bit different. Charges aren't being transferred here, but what's happening is that the negative charges in the balloon are pushing those negative charges away, so we end up with a net positive charge on the left side of the wall, and that is why the balloon is attracted to the wall. You can see that there's a net negative charge on the right-hand side of the wall. So the main point of the simulation is to see how charge is transferred from one object to another, and more specifically to really see that it is the negative charge that is transferred. So if we have a positively charged object, that doesn't mean that it gained protons. What it means is that it lost electrons. And likewise, if we have a negatively charged object, such as the balloon, it's not that it lost protons, it's that it gained electrons. It's always either a loss or a gain of electrons that make our objects charged. So the next thing I want to cover briefly are 3 different ways to charge objects. We just saw charging by contact. When you touch something to something else, then the charge can transfer. So what this is here is an electroscope. And it's just a metal piece of equipment. This is all metal here, this ball, this outer part, this rod, and we have even these leaves, they're also metal, and usually before anything is charged, these leaves are just hanging straight down here. They're just hanging straight down. So what this picture is showing here is we're bringing a positively charged stick nearby. Now this thing is neutral to begin with, so it has positives and negatives everywhere. But when you bring the positive nearby, then all the negative charges start to build up at the top here where the ball is, and so this leaves a net positive charge on the bottom, and this causes the leaves to separate because like charges repel each other. Once we touch the positive stick to the metal ball here, then the negative charges that had accumulated, they will transfer. Because of that contact, the negative charges will transfer to the stick. So the net result is that now this electroscope has lost electrons. It is now positively charged, and even with the stick removed, then the leaves here will repel each other because we have a net positive charge. So that's just one example of charging by contact. The second way is charging by induction, and this does not require any contact. So this example, in this picture, what it shows is two spheres that are neutral to begin with, plus and minus everywhere. And then we bring a positive stick nearby, so the negative charges accumulate on the left, the positive charges accumulate on the right. And while the stick is still there, we separate the two spheres. So the result is that we have negatives on the left, positives on the right. Once we remove the stick, well, those charges have nowhere to go, so the left one remains negative and the right one remains positive. So we have charged these two spheres, which were originally neutral, without even touching them with the stick, but it did require the stick to be nearby while we were separating the two spheres. So that's an example of charging by induction, which doesn't require any contact. And then the last thing I want to talk about is polarization. Now, we already saw this in the balloon applet. So polarization is a separation of charges where the charges are separating within the atoms. So the atoms themselves aren't moving, just the charges are separating within the atoms. So you can see that here. This is like the applet that we saw. If we bring something negative, then the negatives, they separate. And this picture on the right, it shows a simplification, but you can basically kind of pretend that these positives and negatives here cancel out. These ones cancel out right here. They don't really cancel out, but just kind of a simplification. So it really shows you that you do have a net positive charge on the left-hand side and a net negative charge on the right-hand side. So the wall does get charged here, and you are able to stick something like a negatively charged balloon on that wall. So let's finish up this video with one question for everyone. We have metal spheres 1 and 2 are neutral, they're touching. We bring a positively charged rod nearby, and then we remove it. And then we separate the two spheres. So afterwards, what's the charge on each sphere? So go ahead and pause the video, think about this, pick your answer, and then we're going to go over it. Okay, so really need to visualize what's happening here. They're initially neutral, so positives and negatives everywhere, right? And then we bring the stick nearby. So this is just like what we saw in the previous picture, a few pictures ago. The negative charges are going to accumulate here on the left, and the positive charges will accumulate on the right when we bring this positive stick nearby. But the trick here is that the stick is then removed. Okay? Well, once we remove the stick, what's going to happen? These two spheres that are still touching, they're not going to want to stay one negative and one positive. They're going to want to mingle again and go back to neutral. The charges are going to transfer until we have the same number of positives and negatives on each side. And then we separate the spheres, so they're still both neutral. So the answer is actually that the net charge on each one is 0 because they're both neutral. So I thought that was a cool little example to really pay attention to what is happening. If you thought that this one was going to be negative and this one was going to be positive, then you were thinking about the example that we did with induction. However, remember that with that example, we separated the spheres while the stick was still there. So this was a slightly different example. Alright everyone, that's it for this video. We talked a little bit about how charge is transferred from one object to another and different ways that charge can be transferred. I hope that this was useful, and I will see you in the next video.